worked as a CTO on one of the projects. Then I moved to another project where it was mostly about crypto funds and crypto strategies, copy trading, a lot of dealing with compliance, stuff like that. We were quite successful with Economy, and it's still running. And after a while, Web3 became very, very interesting. So I joined the team, the product, which is called Apple today. And at the time, we actually started building Apple as a Web3 development platform. So yeah, Apple is a Web3 development platform. To put it really, easily, or to explain what do I think about what do we feel is a development platform. Apple is trying to be a Web3 Firebase. I would say that's the biggest, the easiest way to compare. On the other hand, for those of you who are old enough and you faced cPanel back in the day, we want to disrupt Web3 development the way cPanel disrupted Web 1, Web 2 development. It made it really, really easy and pushed it forward, and it exists still today. All right, so what do we have as a Web3 development platform? So it is obvious from this perspective of our portfolio offering. So this is what we have currently on our production. We're utilizing different Polkadot parachains, protocols, or services. We are not a parachain ourselves. We are instead very high up, almost at the application layer. And what we do is we cherry pick different stuff from Polkadot. We connect to those parachains. We configure everything in the background. We also handle the payments, and we translate this either into a no-code solution, so you can achieve something on those parachains or on a Web3 infrastructure just by clicking, or you can work obviously over API, SDK, CLI. It is worth mentioning, we also have a Flutter SDK. So if there's anyone out there thinking about, developing something on the mobile sphere, you're more than welcome to do so and to, test it out and start building. Now, as you can see, our product offering is split into three main categories. On the left side, we have services. Mostly when we are talking about services, they are directly driven towards developers who can come and choose a la carte. Maybe they will utilize just one service, such as hosting or storage, or maybe they will cherry pick multiple services and build the full app. And today this is already possible. In the middle, we can see Simplets/Docker. Here we are talking about abstraction above abstraction, right? So how we're thinking in this case is, there are Web2 agencies who every now and then get a knock from a client asking, can you do something with NFTs? We heard, this is something that is happening. We would maybe like to, build some sort of audience or some sort of loyalty program with that. So what we did with Simplets is we basically built the whole solution, including backend, front end, and everything, connecting back to our services, and we open source this, right? So this was our first step, and we did this, I would say, like 1 year ago already. So this is this exists for quite some time. The problem was that we were unable to deploy those Docker images into Web3 infrastructure, right? So the flow here would be, if you were interested in using such a Simplet with us, you would have to basically, take it from our GitHub and configure and host it by yourself. But this is changing very, very soon. So we are already doing internal tests, and it's functioning, where we're able to deploy Simplets and Docker to Phala. For those of you who are unfamiliar, Phala is a parachain on Polkadot, which does TEs, basically trusted execution environment, or in other words, confidential computing, or in other words, hardware encryption, which means if you are able to write the Docker image and you are able to deploy it to Phala, you have guarantees that no one can actually see what's inside. Okay, I see I have some questions in the chat. I will try to address them as we go along. Right, I see you guys know economy, and you go back with Yanni and Mitya. Nice to hear about that. How's Apple changing with the change to Solidity? Okay, yes. So how are we changing towards Solidity? Well, this basically I can answer this from our third column right here. So this is the third category of our offering, and it's called smart contracts. And as you can see, we are supporting EVM only right now. There are some smart contracts that we support that are WASM, but we were very much focused on EVM part. And I would say, this category is very underfed right now on Apple. It's the poorest category we have, and it calls for a serious, expansion. But there's only so much we can do. And yeah, it's something that we'll have to do in the future. But talking about PVM, so Polkadot virtual machine, or future of Polkadot where Solidity will be accepted. Luckily, we are plug and play to that because we are EVM on the smart contract side. All right, so one more question. How would your service compare to Alchemy or Moralis? If you know Alchemy and Moralis really well, and if you understood the offering I was talking about right now, I think it should be obvious, that there are significant differences. I would say, Alchemy is all about RPCs, indexers, and that's probably their main focus. I think Moralis had some sort of storage back in the day, but today I think they are still, they pivoted slightly and they're focused around APIs mostly, while we are trying to provide much wider offering with different infrastructure. So I would say that's the simplest explanation. All right, the question, what's the TEE? So it's a TEE is a trusted execution environment. It's basically renting someone's CPU with a guarantee that this CPU has a hardware encryption, which means you can deploy some sort of code there. And as the code gets executed, even the person who is running it on their own computer cannot see what's happening inside. So TEs are becoming some sort of standard accompanying partner to blockchain, because obviously blockchain has its limits. But if you want to do some sort of compute, and if we look at modern dApps, a lot of them are doing compute and backend still centralized. So TEs are now an introduction to how to avoid that and how to have a decentralized backend. All right, there are too many questions now flying in. We still have 30, 40 slides to go. So I will try and come back and answer those. All right, so this is how Apelon looks like today. If you log into Apelon, you can create an account. You will get immediately 1,200 free credits, which is around $12 worth of credits, and it will be more than enough for you guys to build whatever you imagine in this hackathon. In this situation, you spend all the free credits. You are not obliged to pay. You will just reach out to us and we'll print you some credits, and you will be able to go forward. In the case you will go to production with your product and you will still want to be on Apelon, we will find a way to support you, and to the extent where you start scaling, and we'll find a way, and you should not worry. All right, so how I envision this, we have a lot of services. I picked some of them which I feel would be interesting for you guys. So I have a bunch of screenshots which give you an insight of how the services look like, what you have to do in order to configure them, so you will have a good understanding of what Apelon does and how it looks and feels. All right, so first one, Web3 storage. As you could see, it's built on top of Crust. Crust is utilizing underlying protocol IPFS, which is a decentralized storage solution. And if you want to use our storage, basically you come to our dashboard, you click storage, you create a bucket, and you can immediately start using it. Basically, once you click on the bucket, you can choose to upload, which would mean you are dragging and dropping files. And as you are dragging and dropping files into the bucket, we're the ones who are then taking those files. We're calling Crust. We are also calling pinning in the background, and we make sure those files go into decentralized storage. Other things mentioning here is that Crust is able to do several replicas of those files. So let's say I drag and drop a single image or a logo. Crust will typically create between 15 and 20 replicas. And if one of those nodes drops, Crust will just spin up another replica. So there is guarantee that this file will be accessible at all times. We also support IPNS, which is a name service. So if you find yourself in a situation where each time you upload, you get a new CID, and it breaks your flow in some sort of way, what you can do is you can create a folder on our decentralized storage, which will trigger IPNS, and you will get a fixed CID. Another thing Apple provides out of the box is IPFS gateway, which means even though the files are on IPFS and your users want to reach those files over HTTPS, you should not worry. We have that covered as well. So all of the files that go to IPFS are also cached on our IPFS gateway. All right, so now more interesting for developers. This is the perspective of our API. As I said, initially we have APIs, we have SDKs, we have CLI, and this is how basically you use the storage. You can, create new buckets, you can list files, you can delete files, you can delete directories. You have full control from the software side to do whatever you want with the storage. Our CLI is accessible over npm install, as shown here. Let me see. I see there are a lot of questions bombing right now. So yes, you will get my slides. There are also all the links are within the slides, so worry not about that. What else? What's the pricing model? Okay, so basically from the pricing standpoint, we act as a SaaS, right? So we take care of all the underlying payments. So if you're working a little bit on Crust, a little bit on Moonbeam, a little bit on Astar, you don't have to have those tokens. If you deploy your Dapp and your users do some actions and tokens are being spent, we're the ones who are constantly feeding our bags and settling the underlying transactions, while at the same time we're charging our users in credits, so your credits will get depleted. And in production environment, typically we have Stripe with credit card payments, and we also accept Dot as a payment. So imagine Firebase, imagine AVS, imagine Google Cloud, any of those providers. That's how we want to be. That's how we're acting, with the difference of, you're building with Web2 logic, but with Web3 results. How does the storage solution compare to Airwave? It's a completely different protocol. Airwave is a permaweb, which means, once you store files, they're permanently there. Crust operates slightly different. Once you upload a file, the minimum pinning time is 6 months, but you can extend it up to 1,000 years. And you also have this granular control of saying, I'm going to initially pay for 6 months, and then after 6 months lease is off, you can extend this for a year, 2, or up to 1,000. Now, again, the leases on the storage part are handled by Athlon. We are the ones who are extending the leases. If you give us a signal you want to delete the file, it's going to stay on the IPFS for 6 months, which is a minimum duration. But after 6 months, we'll stop extending the lease, which essentially means deletion. So on Airweave, you cannot delete files. So I would say this is the distinction between them. Okay, I think I answered most of the questions so far. All right, so here are some of the CLI commands. Also, for example, storage list buckets. It will, here is the response you will get. This is how it works. I think it's very straightforward. And if you ever, use the CLI, you will quickly get a hang of it. Some other CLI commands, again, connected to our Web3 storage, such as list buckets, list objects, upload, getting a file, deleting a directory, etc., etc. Another thing we derived from Crust, since essentially Crust is a storage thing, is also hosting. So you can take your static website. Because this is built on top of Crust, there's no server-side rendering, there's no Apache, there's nothing else. So your website has to be static, but essentially you can either drag and drop your Next.js build or React build or Vue build into it, and it will get hosted. Apple.io is actually hosted from our own hosting, our lander website. Our dashboard isn't, but yeah. So this is our hosting. We also have 2 steps that you can utilize. So once you upload the files or your build, you can go into preview, which essentially renders how the website will look like. And then if you say, deploy to production, then we actually start the pinning process. There is an API for hosting, very similar. I will not go over every single function here. I just wanted to point out how this looks like in our docs, and I will provide a link in the slides. What is worth mentioning at the end, so our hosting comes with batteries included, so you can connect your domain. We do have free SSL generation. We are handling the IPNS automatically in the background, which means every time you upload a new website, new CIDs are generated. But if IPNS is in place, you do not have to redirect your domain each time you change your website. So that's pretty cool, and it's there out of the box. What you can do is utilize GitHub Actions. So each time you deploy to GitHub, it will get automatically pulled and deployed into hosting. And as a new feature, we also have short URL generation. What would I like to see you build in the hack? Please be patient. At the end of the slides, I will touch this topic as well. All right. I wouldn't go specifically into what are the compromises and problems of Web3 hosting. You guys, so far, I think you understand this. So now we're moving onto the third service, which are NFTs. So from the NFT perspective, what we offer is a no-code wizard. We're gonna blast really fast through the wizard and how it looks like, so you get a better feeling of how you can really quickly spin up your NFT collections. Obviously, you can also achieve the same result over API and CLI. What we do is out of the box is we build the metadata and we automatically create a bucket in our storage, and we store the metadata into decentralized storage. So we are now, connecting 2 services at the same time. I will display how this looks like. And when we are talking about NFTs, we support 3 parachains right now. It's unique, which is substrate-based and EVM-based, and then 2 EVM-based chains, Moonbeam and Astar. All right, so how does the wizard or no-code solution for NFT collections look like? Basically, again, you log into dashboard, you go to NFTs, you say, I want to deploy a new collection. Once you click it, this is the first step you're going to see. Essentially, we ask you, do you want to prepare NFT metadata with us, or do you have the metadata already available from somewhere else? typically I would say 99% of the cases on Apple choose the first option. Once you choose this, then obviously you have to tell us where do you want this NFT collection to be deployed. Again, we're talking about the same providers as before. And then you start configuring the smart contract and how the collection will, actually operate. We have the capability of adding collection logo and collection cover image. Those are not required. They are not part of the smart contract. They're not part of the standard, but they are nice to have, as a visual help or as a branding help once you deploy the NFT collection. And then essentially, these are the required fields. So this is something where we are configuring, this is where you're configuring the smart contract part. So we have name, we have symbol. With collection type, what you can choose is either generic or you can choose nested. With nesting, we're providing remark standard. So if anyone is familiar with remark, what you can do essentially, let's say you own 3 NFTs, you can click on one of them and nest 2 other NFTs ownership under that one specific NFT. So this is what you configure here. On the next step, you want to configure the collection behavior. So total supply. In this case, we're working with 112 images, which I already prepared before. You can say either the collection is revocable or soulbound. In this case, we set both to no. If you said royalties, 4 in this situation means 4% royalties each time this NFT gets traded after it's minted. And this is the address where you will receive those royalties. This is what you burn into the smart contract. At the bottom, what you can turn on is drop, which essentially gives you a scheduler. So if I would set this schedule to, let's say tomorrow, 9 a.m., that's where the smart contract would allow first minting to start and not before. Here is where you can set a price. So I was deploying on Moonbeam here. So the price is defined in Glimmer. And this would mean every user who wants to mint an NFT from this collection is supposed to pay 0.5 Glimmer. If you enter a certain number and reserve, this allows you to mint NFTs for yourself or to a target wallet directly from our dashboard. All right, so this is a collection preview. Basically from here, what you do is, you proceed. And as you can see, the cost actually is defined in credits. It's not defined in Glimmer because that's how we operate. And I mentioned this before. So if Apple is built on top of different parachains, so, if we're now looking at the blue arrows, this is how we are deriving the functionality into Apple over APIs to developers. But now if we focus on the red arrow, this is where the transaction payments for those parachains happen. So it's something between Apple and parachains, while you guys can just keep on building and you're basically spending just credits. All right, so first part of the NFT collection done. We have the smart contract ready. Well, now we have to start adding NFTs, which is essentially a metadata part. So here you can go one by one, or you can go with a CSV file and do it in bulk. So in this case, we will look how the bulk looks like. I have a bunch of Space Marines, Warhammer Space Marines generated in Midjourney. So yeah, essentially, I just had to choose list.csv. In our flow, you can also get a template for this CSV file. So you will have all the columns already there. You just fill them out and it works out of the box. We automatically detect metadata attributes. Here we are following OpenSea standards. So whatever OpenSea and how they understand metadata attributes, this is what we are following. So if you set metadata attributes in your CSV file, we will detect it and you are able to use that. All right, so we just saw the step where we uploaded the CSV file metadata, and now the second step for the metadata to be complete are the images. So I chose the images from our folder. you can see the preview and walk over, all 113 images. You can even do the final edits here before really committing and deploying. So here, I already mentioned this a little bit, but let's pause for a moment. So what we do here is, and I find it really cool, that's why I wanted to point it out, is an example of service synergy, right? So we were now in an NFT flow in the wizard. User gave us, images and gave us CSV files. So instead of now, asking the user, what do you want to do with this thing, etc., and really complicating stuff, what we actually do is we go to storage, we automatically orchestrate a new bucket. We give it a bucket type metadata. Bucket name is the same name as your collection. And what we do immediately is we put inside two folders. One is metadata, one is images, and the cover and logo, right? So these are the components that user uploaded during the NFT collection creation. And we also generate all the necessary JSON files within the OpenSea standard, as mentioned before. And this gives you guaranteed that your metadata will be stored in a decentralized storage. So I think this is really cool. And this kind of synergy and orchestration is something where we are driving Apple on right now. And you will see more and more features where you can do a lot of stuff just by clicking, and we are the ones who are orchestrating in the background. All right, so here, this is the final step. The collection is deployed, smart contract is deployed, metadata is there. And because Polkadot is right now not connected to any really relevant NFT marketplace, the option we chose here is to offer you guys a pre-made templates for NFT stores, whether in Vue, React, or vanilla JavaScript, that you can take and just configure the collection address, and you can immediately start minting. So basically, you take this template, put it into hosting, and it works out of the box. If you click on this collection, as you can see, base URI is now set on IPFS, right? So metadata is getting served from the decentralized storage. And what you can do is click actions and mint. In this case, I reserved 10 NFTs up front, and I could mint them ahead of time to any desired EVM wallet. Again, this is the perspective from our docs. You can achieve everything I just showed also over our API or CLI. So I encourage you, if you're interested in NFTs, you can also do this as well. All right. The next service, which I think is very, very cool. We built it or launched this. Excuse me, just 1 second. We launched this in November, and I will showcase how it looks like. But essentially, what we wanted to provide with embedded wallets is a completely seamless wallet creation, right? So let's say you are building a Dapp, which is targeting users where they have no wallets or no previous Web3 experience. You have two options. You can either, stop them, and once they click connect, nothing will really happen. So you have to rely on the fact that user has enough knowledge to go to MetaMask, install MetaMask, go over mnemonics, do it really safely, and then comes back to your Dapp and tries to mint something, right? It's quite a tricky thing, and a lot of solutions are already out there which are trying to solve this specific issue. And we are also one of the teams who solved it. And it comes basically in our SDK. And the only thing you need once you enable embedded wallets in our dashboard is these 15 lines of code. If you're working in TypeScript, so Vue, Nuxt, Next.js, React, we have it covered. You can plug and play, and it will work out of the box. So how does this look like? me just find a way to showcase this. So essentially what you will get by installing this code is experience like this. So now the wallet here is already created and it works. But if we were go through the whole flow, I don't think we have the time right now. But if you want to test it yourself, just visit nino.ninja. Click on login above, and you will see how we're utilizing passkeys in order to generate wallets. Essentially, you enter your email, we send you an OTP confirmation, you paste the code, passkey will pop up. If you have the fingerprint reader on your computer, you will put the fingerprint on the reader and wait approximately 10 to 15 seconds, and the wallet is done. User can start immediately using it. They can sign messages. Again, passkey pops up, as you can see in this case. I'm on a Windows machine and I don't have a fingerprint reader here, so it fall back onto PIN, but I was able to sign the message just by doing this, nothing else. So yeah, I think embedded wallets could be part of anything you are building in this hackathon. Maybe you can utilize them somewhere else as well. All right, one more service. So also one of the newer ones, we call this Web3 Cloud Functions. This is built on top of Accurest. Accurest is a DePIN network which utilizes mobile devices of users, specifically mobile devices which come with hardware encryption CPUs, right? So we're again talking very similar as we did before. Again, it has to do a lot with TEs. So again, trusted execution environment, confidential computing. But in the case of our Web3 Cloud Functions, they act as Lambda on AVS. So if you ever worked with Lambda and you want some sort of backend, you can do that. Where is Apelon hosted? Apelon is currently centralized. There is no way of building and abstracting away the complexities in this kind of extent on a decentralized network. It may be possible with the advent of Docker images and trusted execution environment. It is still unclear how the whole architecture would look like and how the payments would work, etc., etc. But even though our dashboard is centralized, essentially, if you deploy the NFT collection and you are calling the NFT collection from whatever website or Dapp, all the results are still Web3. So I would say, yeah, Web2 logic, Web3 results. Whatever you build with Apelon will have Web3 results. Who actually runs the cloud function? So with Accurest, I cannot go. We will run out of time if I will be deep diving into every single parachain. So if you are interested in Accurest and how they actually work, it's then if you know Accurest, then it's clear. So our Web3 Cloud Functions run on Accurest. We basically allow you to come to Apelon. You say, I want to deploy a new cloud function. We give you three basically tabs. One is monitoring, where you will see the amount of calls happening on this endpoint. We give you ability to deploy a new script. It can be a Node.js script. We have the capability of adding environment variables such as secrets, right? If you want to inject them into this execution, and obviously you will also get an API endpoint, right? So this is everything you need with obviously the understanding that that's going to Accurest and is being executed from actual Web3 infrastructure. To make it easier, what you can find on our GitHub is Cloud Function template, right? So there is a template that you can take. You can add your own logic in Node.js or essentially TypeScript. You build it, you come back to Apelon, you say deploy new script, and you deploy it, and that's it. It works. All right, so this is documentation. So you can, again, do a lot of the stuff over API, creating new Cloud Function, deleting jobs, setting Cloud Function environment variables, etc., etc. All right, so I talked a lot, and we still didn't touch Docker in this case. So finally, I would like to introduce how we are thinking in the case of simplets and Docker images. So if you look, we will look at the case of proof of attendance NFTs, simplet that we already built. This Docker image includes an SQL database. It has a front-end solution. It has Express.js backend logic. So everything included here is something coming from Web2, and it doesn't require any specific Web3 knowledge. And as I said, once those Docker images are built, we are going to release this feature very soon, where anyone will basically be able to one click and deploy this to Fala, and everything will get configured for them, and they will just start using this simplet. So let's say this is already true today. You come and you take this proof of attendance simplet, you install it, and you want to access it. Now here, we're talking about something that is happening outside of Apelon dashboard. It's like, imagine installing WordPress to a server, right? You have a server, which is equivalent of Apelon dashboard. You install WordPress, and now you want to admin this WordPress. You want to, create new pages, new posts, etc. This is how you would access the simplet, and this is what you would see. So you would have to predefine who is the admin of this simplet, which wallet essentially is the admin, not the person, but the wallet. And if the correct wallet is connected, you come into this UI. So you basically click, okay, I want to create new, proof of attendance. This only works in the case you already have an NFT collection built. Obviously, you cannot do proof of attendance if there are no NFTs to actually give to people, right? So first you create NFT collection, then you deploy the simplet, and you start managing it. So if you have the NFT collection, you may proceed. You enter some of the data, such as title, description, start date, end date, etc. Quite simple. You see the preview, you deploy it. You can have multiple proof of attendance deployments. And I think this is the cool stuff, right? This is what we also include in this package in order to make it much, much easier for everyone. So we give you two routes. One is for QR scanning and one is for NFT reservation. So if you imagine we're going to, let's say, a crypto conference tomorrow, and we have, 1,000 NFTs, which we want to give out on a booth, right? Once the simplet is deployed, we take a tablet and we basically open this URL on that tablet. It comes already included in the simplet, and it looks like this. So the QR codes will automatically switch every 10 seconds. This gives you a guarantee that, one user, one QR code. If the user scans this QR code, we already built the website where they land and they enter their email. Now, because we are working with a simplet here that has the backend logic also inside, it's Express.js and there's an SQL, we are able to inject those emails into this trusted execution environment simplet, and we have all the guarantees that this is completely safe. Emails never touch Apelon database. We never see them. They actually land into this decentralized infrastructure. So because we know which QR code was scanned by the user and the user enters an email, we can now say, okay, one NFT is now reserved for this user. And we can go one step forward and allow you to configure your own SMTP So the email to this user will be sent over your domain, and then user can come back and mint this NFT. So it's quite a cool solution that basically has everything you need to execute this, and you can achieve everything without coding. So yeah, then you can see, users that signed up. You can see what wallet they used. You can see the status, whether email was sent or the NFT was actually also claimed, stuff like that. So why was I showcasing this specific simplet? Well, it's because what we want you guys to build in this hackathon is your own simplet. It's your own Docker image, which can be built, with Node.js, Express.js, whatever framework you can imagine, whatever framework you are comfortable using. You don't have to think about Web3. What we want you to do essentially is come up with a new simplet, utilize the Docker, utilize our SDK, CLI, API, whatever, and use whatever stack you want for front end and back end. I pointed out some of the stack like TypeScript, JavaScript, Node.js, SQL, because this is what we already have, but you can go the opposite way. You can choose, whatever you want, as long as it works. Now, here are some of the ideas of what I was thinking about, right? So essentially, think about, you have to produce a Docker image, and it has to have a specific use case. So I was thinking maybe we could have a simplet for, Discord token gating. A client comes to Apple and says, I want token gating. They click it once. We have a simplet ready. We deploy it to Fala, so it's in trusted execution environment. Once they log in, we give them configuration, right? They can now configure Discord bot. They can say, what kind of NFT or an asset user has to have in order to be able to join a specific channel. They store this, and the simplet is there running and doing its job. That would be one example. The other example would be token swap Slack bot simplet, right? Again, the same process. We want to be able to take the winner here and their simplet and provide it as part of Apple stack. We want to have your simplet there and available for anyone to deploy and use. So in this case, this one is a little bit out of the box, but I think you will get the idea. So imagine you have a wallet inside this Docker image, and you build it in a way so it's configurable or it's able to integrate with Slack, right? So now what we can do inside Slack channel, we can now talk to this bot and say, can you swap, cross tokens for Glimmer? And obviously bot reacts over the chat and context tree multi-sig over the chat and ask them, are you approving this kind of swap? If on Slack they respond, yes, I approve, the swap is made. Why is this cool? Because you can trust the execution environment to have the wallet, the private keys, and everything there inside, because no one can ever access it. And the only interface needed here is basically Slack integration, which means we're doing swaps over chat. And instead of multi-sig, bot is actually asking for permission for pre-assigned users. I think this would be a very cool example of how we can do stuff. All right, so because we're within the Docker context, we know you guys are building a Docker image. We can think about AI RAG simplet, right? So maybe something with a function where I can say, go and crawl a blog.apple.io. You're able to crawl. We have like 170 blogs. You crawl them, you push them into RAG, a vector database, you configure it in some way. And then we have an endpoint where I can take a new blog, send it there and say, hey agent, can you rewrite this blog so it matches the language of our 170 blogs from before? something like that, maybe, NFT marketplace, Simplet, someone who would like to have an NFT marketplace comes, just clicks once, Simplet is deployed to Fala, and NFT marketplace is there running just for them from this Docker image, and it works out of the box. These are just some of my ideas. You don't have to follow them. You can be very innovative and come up with your own stuff. We will definitely favor submissions that utilize Docker and Apple services. If you find a matching service that we don't have but enables your really great idea, and it's coming from another parachain or something like that, we're fully supportive of that. But let's try and keep it within Polkadot context. Yeah, if you have a crazy idea and you're not sure about it, feel free to reach out to me and verify what I think about it. What does our team think about it before you start building, and we will give you an honest feedback on that topic. So what I have for you as resources here is we have an open sourced POAP Simplet, so the exactly one we saw before. So you can take this as a scaffold. Like if you will pull this or fork it or whatever, you will have a lot of code already there. You could see the logic. You will see how it connects to our NFTs, and so on and so on and so on. And obviously, this is the link to our documentation, which I also showcased in the screenshots before. So yes, this is my final slide. I hope I wasn't too long. I just wanted to really give you a good understanding of what Apple is and what we're trying to achieve. Thank you for enduring this.
We loved it. Thank you very much. I think you